Hi, and welcome to Face Facts. Now, Face Facts takes as input the image of a person, and it tries to predict that person's age, gender, and race. Once again, let's run the app. And so we're greeted with the About section of the app once again. We could navigate on to run Face Facts. And here we're running predictions on this image of myself. And it says I'm 21, I'm male, and I am black, all of which are correct. Now we could expand for more details. And so what is happening here is that it is cropping where it's detecting a face from that image, and it's making it the face of interest for the model to run predictions on. And so the reason for this zoomed in view is that the dataset that it was trained on contains images that look like this. So here we have a confidence score for the gender prediction, and we have there a probability distribution for the race. Now here, Face Facts runs in two modes. Now the first mode utilizes three standalone models, one for age, one for gender, and one for race. And each of these models make their predictions individually. The second mode is single or joint model mode, where the prediction is done by one model. And so one model is capable of predicting age, gender, and race. And you can easily toggle between these modes by clicking on the checkbox right there. And yeah, this changes the predictions, making it worse. I have added 10 years of age suddenly, and my race is now Indian, but it keeps my gender as male. So I'm going to use a different image. I'm going to use that one. This one here. Now what happens is it's going to crop that face, which is the face of my late elder brother, God rest his soul. And so it picks the highest face it is confident on, makes that face of interest. So it detects the age correctly, the gender correctly, and the race correctly as well. We also have 100% confidence that our gender is correct. And so here we could toggle back to standalone models, and we see the predictions become a bit worse, or really much worse. So there isn't a great, so the performance between the standalone models and the joint model varies. So that's about it for the app. So heading back to the repository, we could look at how Face Facts came into existence. Now the goal was to build a model that predicts three entities from people's images. And so naturally the first thing to do is to find a data set. By default, my go-to websites for datasets are Kaggle and RoboFlow. Now after some digging around, I found out that the utk-face dataset is the best available out there, the best free version that's available out there. I did find another dataset, but it did require that I am a researcher and that I request for the dataset. So this right here is me getting the data set from Kaggle. And of course, these data sets are a lot of the time not 100% clean. So this is me doing some data set cleanup. So the labels were not 100% clean. And so I was dropping some of those invalid labels. And so here you probably want to perform some EDA, that's exploratory data analysis, on your data set, just to see how things are spread out. And here we have the regular deep learning stuff. So create a data set, create a data loader, and probably visualize your data set. This is quite important, as we'll see later. So here we're creating the data loader, and so the next thing is to build the model. Now at this point, I had an idea to try out two methods. Now I could have one method predict these three entities. That's like one model to predict these three entities at once, because I thought about maybe there would be some sort of implicit features that would guide, that would help generally in all three areas. And so that was one idea, and then the other idea was to predict all of them individually, right? And so here I'm creating a model, and it's a simple convolutional neural network with about three conv layers, and then I'm using the same architecture basically for each task. I did some playing around, and I found out that there isn't really there's not much advantage to changing the architecture depending on the task. So here for classification with one class, we're using sigmoid. So this is for the gender classification. Regression here is for the age, and classification with more than one class, we use softmax, and that works for race prediction. And here, this is where I implement the single model for the three entities, and really this is what matters the most. And this is where I combine the three losses into one, and then I am optimizing that loss. That's the main difference. Training for about 20 epochs with the 1 neg4 learning rate. And then here is where I'm basically doing about the same thing, but for the standalone individual models. So each of them I'm training for 25 epochs, and here the loss is individual. So yeah, that's about it. That's the thought process for how I came about face facts. So first is to find a data set. Second is to look at the data set, study the data set. The third is to build your model or idea or your approach. And then fourth, to actually train. And so coming to inference, here I am using Streamlit. So after training the models, you'd have to find a way to export them and get them into your inference environment. So this is what I'm doing here. And here I'm trying to use MediaPipe's face detector, because if you have an image, and if you look at an image, maybe a portrait, you have the entire the face and the body, the torso, probably the arms and all of that. Now if you look at the dataset, UTK dataset, we only have the faces, so it's like zoomed in faces, and so we have to replicate that. And so that is what I'm doing here with MediaPipe's face detector. So I'm basically using that to capture one face, turn it into a zoomed view that our model is used to seeing, so that it can make meaningful predictions. And so that's what I'm doing here. This is importing all the models, and here basically this is UI stuff with Streamlit, all UI stuff with Streamlit, and then here is where we run detection. That's the face detection there, and then right here is where we run predictions on the model for age, gender, and race predictions. Yeah, so that's about it. All the rest is UI stuff with Streamlit, and that's about it. I hope this helps someone in their journey. All right, bye. See you in the next one.